Hello, everyone, and welcome to our session called Attestation Everywhere, the path towards making attestation comprehensible and standards-based. Let's start by introducing the speakers for this session. My name is Paul Howard. I'm a solutions architect with Arm, and I'm joined today by Kevin Zhao, who is the data center technical lead at Linaro. So let's begin. Why Attestation Everywhere? Well, we can start by revisiting this statement from the Confidential Computing Consortium. Their definition of confidential computing is the protection of data in use by performing computation in a hardware-based, attested, trusted execution environment. So attestation then is a defining characteristic of confidential computing. And this is representative also of a more general industry trend that we observe, which is that implicit trust in compute platforms is eroding, and attestation is the thing that rescues that situation, because with attestation, we have a way to build our trust explicitly. And we can do this by examining evidence from across the supply chain. But that's a statement that does a lot of heavy lifting because supply chains are complex. Attestation requires data management across numerous and diverse sources. And where there is diversity, of course, there is a risk of fragmentation. And so we have these two major challenges of complexity and fragmentation. And so that's our content for today. It's aimed at addressing these challenges. This is our agenda in 3 sections. To begin with, we're going to look at tackling complexity by making it comprehensible. So I'll be talking about an open source effort to create a hands-on learning platform for attestation. For the second section, I'm going to hand over to my co-presenter, Kevin Zhao of Linaro, and he's going to talk about how we are harmonizing attestation in the Confidential Containers project. And then in the last section, I'll be taking a more future-focused view where we have more alignment opportunities. So let's dive into it and talk about making attestation comprehensible with convenient and approachable software stacks. Now, if you want to understand attestation, then a good place to start is here with the RATS model. So RATS is short for Remote Attestation Procedures. It's maintained by the RATS working group within the IETF. The RATS architecture distills attestation down to its most essential components and data flows. It's a very generic and agnostic model based on these abstract roles and interactions. So it has very little to say about how things are implemented concretely, which is quite deliberate. The goal of this architecture is to establish a common language and thought process. You can apply this model pretty much anywhere where attestation is happening, regardless of the scale or the use case. The evidence is conveyed from an attester to a verifier, and we have a relying party that depends on the result of that in order to make a trustworthiness decision. And then in the background, we have these supply chain actors and owner roles who convey the endorsements, reference values, and policies into the roles that need them. Now, we find the RATS architecture at the foundation of many software stacks that are growing up around confidential computing. It takes on many guises, but fundamentally it's always there. It's the perfect anchoring point then for our quest to make attestation more comprehensible. But it's not an implementation. You can't just clone it from Git, read some docs, and go build it and run it. That's what we'd love to do, right? Those of us who are engineers, if we seek to understand something, we have the itchy fingers, we want to go clone a repo, we want to run stuff and play with it. So what if we could do that? What if we could take the RATS architecture and put it into a box? Something we just execute in its most essential form, something that sits with working software alongside the diagram. And over the past year, Arm and Linaro have joined forces. We've been collaborating on exactly this idea, and this is what I'd like to share with you today. And the goals and principles of this work are listed there on the slide. We wanted to create these guided end-to-end demonstrations, guided in the sense that they're easy to follow through stepwise recipes, and end-to-end in the sense that they cover all of the RATS concepts to a basic working level. And we want to create these experiences from reusable components in open source, and we want these components to be optimized for learning, which means we want to make them small, easy to understand, also flexible, so that they can be repurposed to showcase a variety of attestation use cases. And we want to align on Veraison as the verifier. Veraison is an open source project within the Confidential Computing Consortium. It provides components for the development of verifier services. Veraison is very closely aligned with the RATS working group in the IETF. It exemplifies the RATS architecture along with many of the associated standards efforts within the IETF. So by choosing Veraison as the single engine of verification, we immediately trim away a lot of the complexity that is typically found in some of the larger software projects that use attestation. So again, it's about distilling things down to bare essentials. And we want convenient packaging, minimal dependencies. We want things that are easy to clone and build or just pull from container repositories. So we want to avoid needing any specialized hardware. And there are demos available today for the Arm Confidential Computing Architecture, or CCA. It just runs on software emulated platforms. So it's very easy, just run them on your laptop or desktop, no matter what kind of hardware you have. Now, I did mention Arm, of course, but everything that we're creating here is architecture neutral. So Veraison is an architecture neutral project. We've built demos for the Arm platform, but we would love to see these extended through contribution. They can be extended to showcase other architectures and platforms. So do please consider joining and contributing to this effort. So here's an example of something that we've built according to those goals and principles. You can run this today. I'll share some resources in just a second. It's a straightforward demo of using attestation to control the release of some secret data into a confidential environment. In this case, that environment is a simulated Arm CCA platform, all of which is conveniently packaged as a Docker container that is preloaded with the entire reference software stack for Arm CCA. The secret is managed by a small keybroker server, which runs in a second container and offers a simple REST API. On the right-hand side, we then have the verifier. It's based on the Veraison project, as we saw, but to make things even simpler, Linaro have published a Veraison verifier service on their infrastructure, which we can use. It's publicly available, and it's also pre-initialized to work with the software models for Arm CCA. So if you have Docker and you can access the internet, that's all you need to run this demo. So a quick look through how that works. There's the client of the keybroker running in the confidential VM. So in CCA, we call this a realm VM. It's just a regular user space process that's going to request some kind of key or secret from our keybroker server. The keybroker server receives this request and says, well, no, I'm not going to release the secret. I need to do an attestation first. So it sends back an attestation challenge to the client. The next step, the client takes this challenge and uses it to construct a signed attestation report. There's a common interface in Linux known as config TSM reports, and the keybroker client exemplifies how to use this interface to extract attestation from the system. So that signed evidence, inclusive of the challenge value, is sent back to the keybroker, and the keybroker forwards it on to the attestation verifier. So we default to the one that's published by Linaro, but it's a simple configuration change to use your own Veraison instance endpoint if you want to do that. The verifier will check the signature on the attestation report and appraise its contents. It will examine all of the claims and produce an attestation result. And it's worth emphasizing at this point that all of these packets of data that are being transacted over these links are based on formats that are undergoing standardization by the RATS working group within the IETF. So remember that this is RATS in a box, so we're always striving to exemplify according to these emerging standards. We then show how policy can be used to govern the strictness of that result evaluation. So we have a very small and neat demo here of how OPA and the Rego language can be used to base a trust decision on the contents of that attestation result. And assuming that the trust decision is favorable, the final step is for the keybroker to release that piece of secret data into the protected realm. Now, this is not done in clear text. The client has its own asymmetric key pair that's protected by the realm, and the public part of that key is used to encrypt or wrap the secret in transit. So the last step is the keybroker client will decrypt that secret with its private key and display it to the console. This is just a demo after all, so we want to print something you can actually see And our default secret will say, "May the force be with you," and that's what you will see printed on the screen if you run this demo. Now, I said that you can run this today, and you can. So here's a good way to get started. The ARM learning paths are available at learn.arm.com. There's a huge resource here for learning about all aspects of ARM platform development. If you search for CCA, you'll find several learning paths that showcase confidential computing on ARM, including the demo that I just described. And they all come with these nice, easy step-by-step recipes that will have you up and running very quickly. It's an evolving process, as I say, so we want to build these demo components to be flexible building blocks, and we aim to reuse them to show attestation in different kinds of context. So lastly, before I hand over to Kevin, I'd like to close this section out by referencing two other relevant talks. So at FOSDEM in Brussels earlier this year, Matthew Poirier gave a really excellent talk, which includes a deeper dive into this keybroker demo that I just showed. The slides and recording are available on FOSDEM's website. And then also right here at this conference, and I think it's 1 hour after the end of this talk, so after the keynote, there is this talk from Darshan Patel and Tatsuya Kitamura of Fujitsu on advancing secure processing with Fujitsu Manaka and ARM confidential compute architecture, where they are also making use of some of the components that I've been describing. Okay, so let's switch gears at this point, moving on from demos and learning resources to look at some real-world open source software. Let me hand over to Kevin Zhao to talk about recent work in the Confidential Containers project. So, Kevin, over to you.
Okay, thanks, Paul. Linaro has been working closely with ARM to land the attestation solutions to different open source projects, and we have already finished the support for CCA in confidential containers. So here, this picture is a general schema for Coco CCA work. So Coco is based on Kata containers with more components regarding the attestations, like the attestation service, the keybroker service, and also the attestation agent. The general relationship of the different components can be simplified into 3 parts: the attestation verifier, the reliant party, and the attester. So for attestation part, we've introduced the support for the guest components, support for CCA via the ISI interface, and also for the verifier part, we enable the Coco attestation service support for plugin as a CCA verifier. And furthermore, the CCA verifier can support either the third-party attestation service like Veraison or the local attestation service by Rust CCA token. Great. Yeah. And also, so for runtime part, as Coco is based on Kata containers, we also support the CCA in Kata, which I will describe in the following slides. Okay, so next slide. Thank you. Kata support is relatively straightforward. So Kata container is a virtualization container, which means that a container is running inside a VM to offer the secure isolation. And also it is very seamless to be compatible with the Kubernetes environment. Since the virtualization isolation, it is seamless to change it to support the confidential VM to serve it as a trusted compute base. As we can see in the slides, we add support for the Rust and Golang Kata container runtime. Also, we co-work with the Kata community to maintain the ARM64 CI and also support the Kata deploy with CCA. Yeah, so for VMM support part, we are currently support QEMU, and Cloud Hypervisor is the next step. Okay, the next slide. Yeah, let's back to the attestation part. So for the CCA attestation with Coco T project, currently we have implemented 2 parts. Either we leverage the third-party attestation verifier like Veraison in the top level, and we do all things in Coco locally, or we do all things in Coco locally with Rust CCA token create. In the first scenario, the trustee attestation service will be more or less like a proxy, and all operational complexity is offloaded to Veraison. In the provisioning part, the trusted voucher and the reference value will be provisioned to Veraison. Well, the reference value is also needed to provide to the COCO reference value provider service, where the RAPS client as appraisal needed. So in that case, the third-party attestation verifier Veraison has a function overlap with RAPS service in COCO for the reference value appraisal. The bottom part of the realization is verification locally. We introduce the Rust CC token library to do the local verification, appraisal, and also have a local store for the trusted voucher and the reference values. In that case, we don't need to offload all the verification process to a third-party attestation service. But currently, we need to provisioning and managing the trusted voucher and the reference value manually to a local store, which makes it not very convenient and reduce the TCB. Yeah, we can see for both cases, either way has its own advantage and disadvantages. And in the following slides, we will see how to make attestation easy to approach and management. Okay, next slide. Yeah, so for the attestation, the first one is to adopt the attestation result standardization. Yeah, so in the first scenario, we can also collaborate with, we already collaborate with COCO upstream to adopt the EAR token support as the attestation result. So we can see that after EAR is fully supported, in the verifier part, we can get rid of COCO attestation service and also the reference value provider service to make the key broker service talking directly with Veraison to get the attestation result, to make sure that all the attestation service could be offloaded to the Veraison, the third-party attestation service. Yeah. Okay, so next slide. And the other thing is we can have another new approach to make a COCO trustee work with the endorsement API. Yeah, we can see we do have a local verifier with the Rust CC token, and we can get advantage of the endorsement API, which Paul will describe in the following part. The pain point here for the local verification before is the provisioning. And with endorsement API, we can take Veraison as an endorsement dispatcher server and use it and use a endorsement API client locally to catch or subscribe the reference value or trusted voucher from the endorsement server. So in that case, we can easily to do the appraisal locally and get the endorsement information remotely. So yeah, to make sure that the attestation service will be more simple and easy to management. Okay, so that's all what I want to share today, and I hand over to Paul for the endorsement API information. Thank you.
That's great. Thank you, Kevin. So yes, I wanted to end our session today by turning our attention more towards the future. We've talked about creating standards and about making them comprehensible. And Kevin has talked about how we're incorporating that into software stacks like confidential containers. Now, this is an ongoing process, of course. So I do want to talk about one of the next steps, and it is centered on this problem of endorsement distribution, as Kevin was just describing. I'll bring the RATS picture back again here. So we have seen this a lot today. The RATS architecture is quite theoretical, but we can use it as an analysis tool and intersect it to find real-world industry problems. We can illuminate those places where there are the most fruitful opportunities to standardize and harmonize still further. So here's one area highlighted, which is this conveyance of endorsements and reference values from the supply chain to the verifier. Verification can't happen in a vacuum, so verifiers need scalable access to these endorsements and reference values. Scalable being the key word. Recall that supply chains are complex, they are diverse, there are many points of production and consumption. When you really think about the number of business entities involved in this, from silicon all the way to applications, it really is an industry-wide data management problem. Lots of different vendors, huge potential for fragmentation, and that's what we want to avoid. And the RATS working group is the ideal place to do this, because we can see very clearly here that it's part of the RATS model. So I want to end by highlighting some work that's going on to create new specifications in this area, coupled with prototyping efforts to showcase them and prove them out. So during last year, I spent some time raising awareness of this opportunity to improve the endorsement story. I've been giving presentations to communities such as the OCP, the RATS working group, and also the CCC Attestation SIG. And we've been building this community of expertise and practice that's helping to progress this work. At FOSDEM this year, I had the chance to meet with some of those individuals. As you'll see from the photograph, we had to improvise somewhat in terms of our meeting space, but it was a productive meeting if it wasn't a comfortable one. And we've aligned around exactly this two-part strategy of working on designs within the RATS working group. There are still active discussions on how we might modify existing RATS internet drafts and where we might introduce new ones. But for the time being, we're using a more informal resource. We have a wiki page where we're collecting thoughts and requirements in that community. And coupled with this design effort, we want to create a working POC. And Kevin was talking about this earlier, right? The idea of using Veraison as a dispatcher for endorsements. It's the perfect experimental platform for this exercise. It already has the components that are capable of both publishing and consuming endorsement data. And it also has a strong history of being a proving ground for RATS designs. So a POC is what we would create initially, but then we don't rule out upstreaming this as a mainline feature of Veraison in the future. And then that comes full circle, right? Because if Veraison is our proving ground for these new specifications and APIs, then that feeds nicely back into the educational program I talked about at the beginning as well. So our demo stacks could demonstrate endorsement flows in addition to verification flows. And as Kevin has already spoken about, this could be incorporated into software stacks like confidential containers as well. If this sounds interesting to you, then by all means, feel free to get involved. That wiki page is a good initial resource. But by all means, also drop me an email and I can connect you into those conversations. And that brings us to the end of our content today. So on behalf of Kevin and myself, thank you very much for listening. And I hope we have time now for some of your questions. Thank you.